Next topic is limiting reagent. So limiting reagent means the reactant which is completely consumed during the reaction and limits the amount of product formed. So once again I am telling, so limiting reagent means the reactant which is completely consumed during the reaction and limits the amount of product formed. See one example. So after seeing that example, go for one problem. Suppose x plus y combine to form xy. So in this case, x present is, imagine if it is 1 mole of x and 1 mole of y combined to form 1 mole of xy. So 1 mole of x and 1 mole of y combined to form 1 mole of xy. Suppose if it is 1 mole of x, 5 mole of y combined to form how many moles of xy? So you have to calculate. So 1 mole of x and 5 mole of y combined to form how many moles of xy? So already we know. So 1 mole of x combined with 1 mole of y. So 1 mole of x combined with 1 mole of y. 1 mole of y. So out of 5, 1 mole is reactant, means remaining we have 4 moles. This 1 mole is completely reacted with 1 mole of y. This 1 mole of x is completely reacted to 1 mole of y, but only 1 mole of y is reacted, remaining 4 moles is left. So this left they call it as excess reagent. Call it as excess reagent. And this X they call it as limiting reagent. They call it as limiting reagent. Limiting reagent means smallest amount that is completely takes part in the reaction. That is completely consumed in the reaction. So only smaller amount which is completely consumed in the reactions are said to be limiting reagent. The reagent left are called as excess reagent. So let's see one example. So in this example, in a process, 646 gram of NH3 is allowed to react with 1.144 kilogram of CO2 to form urea. So they given the equation 2NH3 plus CO2 gives, this one is urea formula, urea along with water. So in this sum you have to calculate. First they ask, if the entire quantity of all the reactant is not consumed in the reaction. So they are asking whether all the reactants are consumed in the reaction. Second, which one is the limiting reagent? If the entire quantity of all the reactant is not consumed in the reaction, they are asking, then they are asking which is the limiting reagent, either NH3 or CO2. You have to find out which one is limiting reagent. Second, they are asking calculate the quantity of urea formed and the unreacted quantity of excess reagent they are asking. So they are on how many amount of excess reagent. So you have to find out excess reagent and limiting reagent, and you have to find out the quantity of excess reagent. So first we will start to find out the entire quantity of all the reactant is not consumed in the reactions or not, we find out. Then we have to find out limiting reagent and find out the product formed and how much amount of product is formed, and fourth one we have to find out the excess reagent. So this one is table. So in this table, NH3 react with CO2 to form urea along with water. So first step is stoichiometric coefficient, means balanced equation. This one is balanced equation. You see 2 nitrogen. So 1 to 2 nitrogen, and hydrogen is 6, 2 3s are 6, so 2 plus 4 plus 6, so hydrogen is also balanced. Oxygen is 2, so 1 plus 1 2, carbon is 1 1. So this equation is stoichiometric equation. Stoichiometric equation means balanced equation. So first we have to find out the stoichiometric coefficient. Stoichiometric coefficient means, so in the balanced reaction, before the reactor the number given. So in the balanced equation, before the reactor number given. So in this reactant, NH3, so number given is 2. So stoichiometric coefficient for NH3 is 2. For carbon dioxide, they didn't give any number, means I said it is 1. So 1 mole of CO2. In case of urea, they didn't give any number, so consider to be 1. So water also 1. Second step, we have to find out number of moles of reactants allowed to react. So you have to find out reactants. So mole formula already we know, mass by molar mass. So they given 646 gram of is allowed to react with 1.144 kilogram of CO2. So they given 646 gram of ammonia. So mass they given as 646. Then molar mass of ammonia. Ammonia formula is NH3. N nitrogen atomic mass 14 plus number of hydrogen 3 into 1. So 14 plus 3 comes as 17. So molar mass is 17. So on dividing 646 by 17, we get 38 mole. So answer is 38 moles. Second, they given 1.144 kilogram. So 1.144 kilograms, you have to convert it into gram. So kilogram to gram means you have to multiply by 1000. So when you multiply 1.144 into 1000 means we get it as 1144 by carbon dioxide molar mass. So carbon dioxide formula, so they given CO2, carbon atomic mass 12 plus number of oxygen 2, oxygen atomic mass 16. So 12 plus 32, 44. So carbon dioxide molar mass is 44. So on dividing this we get 26. So the answer is 26 moles. So no need to find out product because they mentioned number of moles of reactants allowed to react. So no need to find product. So third step, actual number of moles consumed during the reaction is they given in the ratio 2:1. This for this ammonia, number of moles is 38. So write it as 30 moles. In case of carbon dioxide, 2:1. So 38 divided by 2, you have to take the half of the ammonia. So half of the ammonia means 38 by 2, it comes as 19 moles. So this is on actual number of moles consumed during the reaction ratio. Remember the ratio 2:1. So first you consider this one first 38 moles. So I mentioned 2:1. So half of this will give 19 moles for CO2. And fourth step is number of moles of product is formed. So product calculation, so they ask only product, so no need to find out this reactant, straight away go for product. So already we know they given in the ratio 1. So already we calculated 38 by 2, we considered 19 moles because the ratio is 1. The same amount you have to take, this amount, because the ratio is 1. So you have to divide by 2, 19 moles. The same value you can write here because 19 into 1, so 19. Here water also 1, so 19 into 1, 19 moles. So final step, number of moles of reactant left. So number of moles of reactant left at the end of the reaction. So you have to subtract this 38 minus 32, absolutely no value, so nil. In case of 26 minus 19, so balance we get 7 moles. So they ask only reactant, so no need to find out product. So we calculated number of moles of reactant left and product formed and actual number of moles. So already I said limiting reagent means smallest amount which is completely consumed during the reaction. So in this reactant you find out, so 38 minus 38 didn't get any value. That means all the ammonia, there is no formation, there is no left vacant for NH3. That means all the ammonia takes part in the reaction, or all the ammonia is consumed in the reaction. So in this reaction, NH3 is a limiting reagent. because it is completely consumed in the reaction. So NS3 is a limiting reagent. So finally the left number of moles of reactant left we have 7 moles. So it is a carbon dioxide. So carbon dioxide is an excess reagent. Carbon dioxide is an excess reagent. Because ammonia, when you subtract 38 by minus 38, so now no value. That means all the ammonia is completely consumed in the reaction. But in case of CO2, we have left 7 moles. So that is this CO2 is said to be excess reagent. So in the sum, they ask if the entire quantity of all the reactant is not consumed in the reaction. But in this case, ammonia, the entire quantity is consumed in the reaction. Ammonia is consumed in the reaction. So entire quantity of ammonia is consumed in the reaction. Then they ask which is the limiting reagent. Limiting reagent, and find out it is NH3 is a limiting reagent. And second, they ask calculate the quantity of urea formed. Quantity of urea means amount of urea. So amount of urea formed. So already we know number of moles formula, mass by molar mass. Here they ask amount means mass we have to find out. Then cross multiply this value. So mass equal to N into molar mass. So mass is equal to N into molar mass. So N value, number of moles for urea. Here find it out. It is as product formed as 19 into molar mass of urea. This is mass of urea. So molar mass of urea. Urea formula NH2 CO NH2. So molar mass calculation. Number of nitrogen 2. Number of hydrogen 4. Carbon 1. Oxygen 1. So 2 into 14 plus 4 into 1 hydrogen atomic mass plus 1 into carbon atomic mass 12 plus 1 into 16. So 28 plus 4 plus 12 plus 16. So 28 plus 4 32. 32 plus 2 34 plus 10 44 60. So molar mass is 60. So 19 into 60. When you multiply 19 into 60, we get the value of 1140 gram. So this is the amount of urea consumed. This is the amount of urea formed during the reaction. And then we have to, they ask unreacted quantity of excess reagent they are asking. So excess reagent here is CO2 is an excess reagent, so you have to find out excess reagent quantity. Similar way, same method. So amount of CO2, because they ask quantity of excess reagent. So excess reagent here it is CO2. So amount of CO2 calculation. So mass of same method because mole formula N is equal to mass by molar mass. So we have to find amount means you have to measure mass. Suppose mass means you cross multiply N into molar mass, that is number of moles into molar mass. N denotes number of moles. So here N into molar mass. So number of moles. They ask unreacted quantity means left. How many moles left during the reaction? 7. So 7 into. Already we know molar mass of CO2 is 44. So 7 into 44. On multiplying we get 308 grams. So this is all about limiting reagent. Limiting reagent, smallest amount which is completely consumed during the reaction is said to be limiting reagent. Then one which is excess or left behind are called as excess reagent. So understand this topic, because based on this topic they will ask problems only. They will ask sometimes limiting reagent 2 more questions, maximum they will ask problem. So I will give one problem as homework, you try this. Same method, you try that sum. This is the sum. This is the sum. So in this sum, in a process, 320, that is a book bag question, 324 gram of aluminum is allowed to react with 1.12 kilogram of ferric oxide. So they given the equation. So you have to find out mass of Al2O3 means. So you have to find out the amount of product formed. Then we have to find out how much of excess reagent is left. So you have to measure the excess reagent left at the end of the reaction. So you try this sum as homework and find out, same method you try this and find out this sum.